Oh, hi there. So in this video, we're going to practice the concepts of terms of trade. We're going to do 5 practice problems where we try to determine, is this deal good or not good for the buyer or the seller? So let's get started. Okay, so our first problem is an output problem. It tells us that in 1 hour, Dana can make a certain number of this and that, and Robin can do that too. In order to do this, we're going to need to go ahead and take that comparative advantage table, set that up here in the corner. Dana and Robin, and what are they making? They're making smoothies and pizzas. 4 food groups, right? The 2 food groups. Dana can make 20 smoothies or 10 pizzas, and Robin can make 30 smoothies, good for you, Robin, and 6 pizzas, not as cool. Would the following terms of trade be acceptable? Circle the answer, then explain. So in order to do these terms, we're going to need real quick here. I'm looking and it says 1 pizza, 1 pizza, 1 pizza. So I'm actually only going to do the 1 pizza side. Remember, we typically are only going to have the terms expressed in something where there's nice whole numbers, not fractions. So you kind of be able to see like 1 pizza, 1 pizza, 1 pizza. I'm going to go with the pizza column because that's where I'm going to be able to compare the smoothies. So I take the outside number over because it's an output problem. 20 over 10 is 2 smoothies. And then for Robin, 1 pizza, 30 over 6 is 5 smoothies. And so we know that Dana is producing the pizzas, and we know that Robin is producing the smoothies. But that's kind of a moot point, right? We know really that Dana is the seller of the pizzas. We also know that Robin is the buyer of the pizzas, and that this is his maximum price, right? And that's Dana's minimum price is 2 smoothies. So get in the habit of kind of thinking about these as like, this is the seller, this is the buyer, right? The lower and the higher price. We know that the seller is the one with comparative advantage because they have the lower opportunity cost. They should specialize in and do that. 1 for 1, let's see. Well, that doesn't fit in between the 2, right? There's not a 1 in between 2 and 5, so that's not going to be good. It's going to be bad. And it's actually going to be bad for Dana because, right, we're actually looking at like, is it good or bad for this person? And so it's bad for Dana. It would actually be good for Robin. And that's because 1 smoothie is less than 2 smoothies, which is Dana's opportunity cost, right? So we're really saying that this smoothie is below the seller's minimum point. 1 pizza for 10 smoothies, right? When thinking about for Robin, well, that's bad for Robin because we'd say 10 smoothies exceeds his 5 smoothie, Robin's opportunity cost, right? So we're really just, again, comparing to their minimum and maximum prices and thinking about it as their opportunity cost. 1 pizza for 3 smoothies for Dana. So that is in between the 2. It's actually good for both of them. But so we'd say 3 smoothies exceeds 2 smoothies. And you get the idea that that's Dana's opportunity cost. So just as we kind of really quick here to see like, what would that look like maybe on the other side? 1 for 1, well, that would be really good for Robin, right? So that's below Robin's price. So if this question had said for Robin, we would say it's good for Robin. For the second one, pizza for 10 smoothies, it's bad for Robin, but it's actually really good for Dana, right? Because 10 is bigger than 2. So it's useful to remember that with all these ones where they're bad for one of the 2 parties, it's going to be good for the other one. In the ones we're looking for is where it's good for both, right? So we could actually say that this third term is good for both. Using equal resources, Atlantis and Xanadu, this same problem again. And so we're going to set this one up one last time. Atlantis, Xanadu, helmets, baseballs. It does say 1 helmet for 3 baseballs, so I am going to play in the helmets column. They both can make 100 helmets, and it looks like Atlantis can make 200 baseballs, and Xanadu can make 400. So we're playing in the helmet column because it gives us 1 helmet for 3 baseballs. So that's what tells me which column to look at, right? I take the 20 or the 200 over the 100, that's 2 baseballs, 1 helmet here. 400 over 100 is 4 baseballs. And so I'm looking for a number in between 2 and 3, and I got it. So yes, they would both benefit. Yes, because 3 baseball, well, it's actually easier to say it with because 2 baseballs is less than 3 baseballs is less than 4 baseballs, right? Which then we can kind of say A's op cost here, and we can say Z's op cost here. And that's enough to kind of demonstrate that we understand, hey, we're trying to be in between these 2 opportunity costs. That's really all you got to say. Given the PPCs for A and B, identify a mutually beneficial amount of wheat that would be exchanged for 1 unit of cloth. So again, I'm actually looking for 1 cloth for how much wheat. I'm just rewriting that question just off to the side for myself. So let's say here we have A and B, cloth and wheat, and we know they can both make 100 wheat. and that country A can make 100 cloth and country B can make 300 cloth. And it is saying one cloth, so I'm going to play in that column. So we know that this is a 1-to-1 because 100 over 100, right? But 1C here, 100 over 300 is 1/3 of a wheat. Now, it's got to be in between, right? How much wheat would be in between that? Well, some number in between. We got to identify a number. We could say half of a wheat, right? That would work. So let's say 1/2 wheat because, and then you can say essentially 1/3 wheat is less than 1/2 wheat is less than 1 wheat, and then again making references to who these belong to. So that's B's op cost and A's op cost. So again, I'm just kind of justifying why it is that I'm saying that this would be an acceptable trade, right? 1/2 is in between these two numbers. Stefan and Donna, orange juice and canvases. That's a weird combination. There's a lot of those in econ, but man, that one is strange. Hey, I have some juice. Would you like a canvas? Heck. All right. So we're going to do the same process here. Donna, Stefan make an OJ and canvases, which is weird. Stefan can make 40 liters of juice. That's also strange. It's like an art commune that makes juice. I'm kind of envisioning this, like people plucking oranges, making them, and also maybe some art. Amount of juice for one canvas. So again, we're doing one canvas for how much OJ. So I'm going to play in the canvas column this time. One canvas equals 2 OJ, because that's 20 over 10. And then over here, one canvas is, I got to be careful here that that's 2 OJ, not 20. So maybe I'm going to just say 2 juice, actually, just to make sure that I'm not screwing this up. 4 over 3 is 1 1/3 juice. So it's got to be something in between these two. Let's say 1 1/2. How about? So 1 1/2 juice because, and then we can say 1 1/3 juice, which is S's op cost, is less than 1 1/2 juice, which is less than, and on a test, by the way, you're going to have lots more space than this, which is less than 2 juice, which belongs to Donna's op cost. So again, not that hard. It's really just kind of getting in the habit of figuring out, well, I got to figure out a number in between these two, 1 1/2 or 1 1/3 and 2. Last but not least, we got same amount of time and resources. Jack can make 10 bikes and 5 computers, blah, 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 blah. Wrap this bad boy up, put a bow on it. Jack and Sam, they're making bikes and computers, which is also another weird combination. Jack can make 10 bikes and 5 computers. And we said that Sam can make a 1-to-1. Okay. And it says 1 computer, so that's what's going to tell me. Again, I'm playing in the computer column on this one. So 10 over 5 is 2 bikes. Is that where we're making bikes? Yeah. And here it's 1-to-1. So a mutually beneficial number of bikes for 1 computer would be anything in between 1B and 2B. So again, let's just say 1 1/2, 1 1/2, 1 1/2 B, because 1B, which is Sam's op cost, right, is less than 1 1/2 B, and that's less than 2B, which is Jack's op cost. And again, on a test, we want to probably put a little box around the correct answer just to show that we have the answer here. And then writing out our explanation is totally fine like that, right? Thank you so much for playing around with terms of trade. It's one of the hardest concepts. I'll see you next time.